extend these lines infinitely, but there's only one, those three things are only going to form a closed region once, which is that one. You got to like read the words exactly. The region enclosed by these three things. Okay, so what shape is formed?
It's a cone.
Yeah, like a flattened surface.
Yeah, okay, I like that answer. Yeah, it's like a cone tornado sort of thing. It's like a this, right? It looks kind of like a tornado, it looks kind of like a cone, it looks kind of like a trumpet thingy, or maybe like some weird trumpet bell of some weird brass instrument. Looks kind of like, what?
I think that's
Good. It also looks a little bit like a sorry piece, I think. Okay.
Yes.
Alright, so now, goal, figure out the volume of this thing. Well, what we need to do to figure out the volume of this is to slice it up into an infinite number of infinitely small pieces. What are those pieces? Or how should we slice it?
Rectangular prisms.
Like this, right? We're going to slice up this thing like this. And since we're going to slice it like that, what we're really going to do is we are going to just take one little representative rectangle, which is why I insist that you draw a representative rectangle, and we are going to rotate that representative rectangle about the x-axis. And the shape of one slice is going to be whatever happens when that representative rectangle gets rotated around. Follow? So what happens when that red representative rectangle gets rotated about the x-axis? What shape is formed? A cylinder, yes, but it's a very, very short cylinder. Does everyone see that? And since it's a very, very short cylinder, we call it a disc. That's like like a disc, a fritz disc or whatever. What is the radius? Nicola, you're pissing me off. What is the radius? Stop talking. Don't say a word. I don't care. Don't say any more words. What is the radius of this disc? Yeah, the radius of the disk is like the y value of the function, right?
Yeah.
And what's the height of the disk?
Delta
X, right? Exactly. And so what I'm really doing is I'm taking the interval from 0 to 2, and I'm partitioning that interval up into subintervals. And then I'm going into the ith subinterval, I'm choosing a sample point x sub I star, and then I'm saying, okay, for that sample point x sub I star, what is the height of this red rectangle? And the answer is x sub I star squared. Yeah? Okay, and that height is the radius of the disk. And so what I'm doing is I go in and I find the volume of just one of those tiny little disks. The volume of just one of those tiny little disks is, it's like pi r squared h, right? So, but in this case it's pi. The radius is x sub I star squared, right? Say right? And that gets like squared again, because it's r squared, times the height. What's the height of that infinitely tiny disk? Delta x. And what am I doing with all of these little tiny guys? Adding them all up from I equals 1 to n, and then I take the limit as n goes to infinity. So the limit as n goes to infinity, the sum from I equals 1 to n of a whole bunch of little very, very thin disks, each of which has height, delta x, and has radius, whatever the y value of the function is. Okay, so this becomes an integral. What integral? The integral from 0 to 2. Function is x squared, but the value of the function is the radius. It's the fourth. Right? You good? Cool. Are you guys with me? Shall we good? I'm not good? Yeah, okay, so now we just do it. I guess this is like pi x to the fifth over 5. I got 32 pi over 5. Is that what you got? Alright, I think it's kind of awesome. Okay, good. 3 more to do before the bell rings. Number 2, go. Read it, think about it, read it again, draw a picture, reread it to make sure you understood it properly. Shade. I really recommend drawing a region. I guess you did that. Draw the region, label your figure, draw a representative rectangle. Big picture. So now the region under discussion is the region enclosed by x equals 0, y equals 4, and y equals x squared. So did you guys get this for the region? Okay, good. Please make sure you have big picture, region clearly labeled. What am I doing with this region? I'm rotating about the y-axis. Okay, so now that you have this all good, mark it. And then, just like use your imagination. What shape is formed? Like a kind of bowl.
Anemometer.
Like a what?
Anemometer.
I don't even know what that is. A what?
Anemometer.
Anemometer?
Mushroom
Yeah.
tip.
Oh, yeah. Okay. Whoa. This guy's like, no things. Yeah. So, I would like to find the volume of this anemometer. A word I just learned. How do I do that? The answer is always the same. Slice it up into a number of different small pieces and add them up.
Yes.
How will I slice though?
Horizontal.
Yeah, now I can like only really slice horizontally, right? So if I'm slicing horizontally, that means that my representative rectangle therefore must be sideways, right? Is that right? Which forces me to do what? To like integrate with respect to y. Exactly. And so now, if you think about what's really going on, Nikili! God! This is the curve y equals x squared, Nikili, but that's not the form I want the curve in. What form do I want it in?
In the sigma thing.
What the hell are you talking about? You're not paying attention, so you don't know what's going on. We just decided a minute ago, while you were goofing off, that we need to integrate with respect to y. And so if we need to integrate with respect to y, then what I need for an arbitrarily chosen, what I'm again doing is I'm partitioning the y-axis between 0 and 4 up into subintervals. I'm going to the ith subinterval, I'm calling that y sub I star, and then I need to know for an arbitrary y sub I star, I need to know what the height or what the length of that red rectangle is, right? Because that will tell me what the radius is. Follow? Thus I need to express x as a function of y. X is just root y, which is a formula for the height of the rectangle. And so I need to, the area of one of these little disks is pi r squared, so that's pi r squared h rather. So it's pi times the radius squared. What is the radius in general in terms of y? Yeah, it's like root y sub I star. And then what's the height of the disk? It's just delta y. And then what do I do again? I sum them up from I equals 1 to n, and I take the limit as n goes to infinity. So this turns into what integral?
Integral from 0 to 4.
Integral from 0 to 4,
Pi on the outside.
pi on the wherever it goes,
Y.
y dy. Yep. Sprinkle some magic calculus pixie dust. The Riemann sum turns into an integral, and then, see, isn't this kind of amazing? I think this is like the coolest thing ever. I'm solving this problem basically by turning it into an integral, but the logic is still dictates that you begin with the Riemann sum. All right, do this integral and then go to the next problem. I got 8 pi. Is that what you got?
Yes.
Good. Next problem.
Make a big zoom in. 0. Oh shoot. Can you make it gigantic?
Yeah, if you make a picture and then you realize that your picture kind of sucks, don't be afraid to just erase it and start over again. Better to have a good picture than a tiny, wrong picture.
I don't care. It's okay to suck. It's like a P. Banana. I grew up without It's like a banana that's like straight up. No, but there's two. Yeah, well, there's two. I don't understand. It's a chorus. No, because this side isn't open. This side isn't open. Trice. That's what they
Okay, so now the region is the region enclosed by y equals x and y equals x squared. And how am I rotating this region? Around the x-axis. Okay, so I draw my curves. I draw the points of intersection. I shade the region. I notate that I'm rotating about the x-axis. Now, what kind of shape is formed? Hard to describe.
Cone with a surface area cut out.
It's like a cone. Yeah, it's like a. It's like a this. It's kind of like some weird flower thing, or like a mold for a sari piece, or a. It's kind of like sometimes like if you go somewhere where they try to like rip you off and they give you like drinks, but they don't want to give you too much. So then they just like, they pad the inside of the cup in such a way that you're actually getting even less than it looks like. Yeah, that's the thing. Some people do that. So anyway, I would like to find the volume of this thing. How should I slice it up in order that I may find the volume? What's up? You could do that, yes. You could, yeah. But if it weren't such a simple thing like cone, then you wouldn't be able to do that. So let's do it more in general.
Vertical.
Yeah, I'm going to make cuts like this, right? Because I sort of have to, because I'm rotating with respect to the axis. So now I draw a representative rectangle, but now the representative rectangle is going to look like this, right?
It's going to be minus.
Okay, so what shape is formed when this representative rectangle is rotated about the x-axis? Everyone take a minute and visualize it. Kelly.
A washer.
Kelly.
Sorry.
So a washer?
Yeah, a washer, which is kind of just like what is a washer?
Donut.
It has a hole in the middle.
A bagel.
Yeah, it's not really a bagel, actually. It's a washer, because bagels are curved on the edges, but these aren't, right? It's a, it's like a, Calvin, it's just like it's like basically like a cylinder with another cylinder cut out of the middle, right? But they're really short cylinders. So it's like a washer, like a washer, that you use like in whatever, building things, like a nut bolt washer. Yeah, like a washer. Okay, how do we draw this washer? It's like kind of hard, and I am bad at it, but it is something like this. It's like here's the thing, and then there's sort of like two functions now, right? There's this function, which I'll call the inner function, and then there's this function, which I'll call the outer function. And if you have these two functions and they get rotated, here's where I need like help-ish. If you rotate them like about, this is okay, about the center, then are you guys sort of seeing the washer? Bad artist. But there's like this, I just am not good at like perspective and crap, but like the thickness of the washer is like delta x. Is this kind of like helping? Yeah. Despite my bad picture, Sherry Fenn understands what I'm getting at now. That's my washer. So what is the volume of a washer? Or what's the volume of this thing? It's just the outer cylinder minus the inner cylinder, right? So it's going to be like pi r squared for the big one. Well, the big one is going to be like g of x squared, right? Pi r squared, h is delta x. And then just take out the cylinder that's missing from the middle, which is pi f of x squared delta x. You guys with me? I think you are. Okay, good. So Liam, if that's the case, then I now need to get in the really good habit of drawing the sort of inner radius and the outer radius of my representative rectangle. What is the inner radius for an arbitrarily chosen x value?
F of x.
The inner radius?
F of x squared.
The inner radius is x squared, right? And the outer radius? X. In terms of x, right? So you pick an arbitrary x on the x-axis between 0 and 1, and then you have to sort of draw in what's the inner radius, what's the outer radius. All right. So since that's the case, what can I just go straight to the integral this time because we're like advanced and stuff?
Yeah.
Kellen, what integral will solve this volume problem?
0 to
1.
I guess. Yeah.
All right. Kellen passes it on to Alianwar. Alianwar.
It is 0 to 1.
Yep.
Pi on the outside, and x squared minus 4.
Yeah, it's the outer radius squared minus the
Inner radius squared.
inner radius squared. And all of that times dx. Does everyone see what he did here? He basically just said, yo, it's a cylinder with which is very short, minus another cylinder. But I can sort of factor out the pi, and I can also factor out the delta x. And so the general pattern is, it's just pi inner radius squared minus outer radius squared delta x. Okay, so now we just have to do this integral. So I don't know, do it really fast. I don't know, what do you get?
2 pi over 15.
I think it's, is that true?
Yeah.
Okay, good. So x cubed over 3 minus x to the 5th over 5. There's a pi out here, 0 and 1. So it's like a third minus a 5th. That's 2 pi over 15. Okay, good. You guys feeling good about this? Okay, last problem, and then we are done. This is the hardest one yet. It's number 4. 4. Yeah. Read it, think about it, draw a picture. Love you guys. I'm not screaming at students on video today.
Yeah, very good.
Yeah, good. It's like crazy.
Actually, it is smaller. This is awful.
Mr. Rose, I think the battery is almost
What?
out. It says,
Out?
No,
Or low?
but it says change the battery.
Okay, yeah, blah, blah, blah. We'll be done in like a minute.
It's like this is true. Yeah.
Okay, so if we draw y equals x squared, and we also draw y equals x cubed, they intersect. When people say the region bounded by y equals x squared and y equals x cubed, it's just this tiny sliver of a region, right?